Hi everyone, I'm Martin and welcome to Astronomy for Beginners, and today I'm going to do a video guide on planetary imaging. Now, obviously I mentioned this before on the previous guide on imaging on planets, is that I'm just going to detail a few hints and tips on getting the best possible image quality of planets. Now, believe it or not, my setup here is I set up my telescope and matched off 127, and I basically set this up basically in the garage. Right, I have this stored in the garage, and when it's sort of clear night, I get it set up. I got my laptop here on my table there, and it's rigged with me quality planetary camera, which is the QHY IM32E. Right, and basically I set it up, set up my alignment, and I'm off I go. Now, previously you've probably seen my latest image, and probably the best image of Jupiter yet so far I've achieved, and you can achieve absolutely amazing results. Now, basically what I'm going to do with this guide is going to show you a few hints and tips to get the best images possible. Now, as I mentioned before, first thing I need to clarify is a lot of telescopes, particularly the maxitop and reflectors, and sometimes refractors and cascades, is that they suffer from a lot of turbulence, right? And that turbulence is due to the heat of the optics. So basically the optics are quite warm. Took it outside from your living room where your telescope was stored. You have to take your time for the telescope to cool down. Basically, cool down means give it about an hour or so, depending on the size of the optics. For this telescope alone, obviously for my house, and I image with it, I let the optics cool down for about an hour. Very crucial. Alright, you'd be surprised at how much image quality you can achieve when the optics are cooled down. Now, biggest tip is, because it's in the garage, I basically leave the telescope in the garage, alright, and I lock it up at night or during the day. When I need it, I bring it out because the optics are already cooled automatically. I can basically begin imaging straight away. Another tip is, as you do your star alignment, alright, it's very crucial that when you're imaging planets and all that, is make sure your star alignment is spot on. Alright, it needs to be spot on, and the best way to do it is usually 9 times out of 10 you get these finder scopes which are adequate. Now, to get pinpoint accuracy, alright, it's best to do the setup during the day. Alright, so when you align your finder scope, adjusting these screws here, basically what you're trying to do is line up the crosshair, focus on some trees out there, and or a building quite far away. Now, the biggest mistake is that a lot of people start out straight away trying to expect to see something. Right? You need to set up the finder scope as accurate as you can. Once it's in line with the crosshairs, alright, you need to make sure that it's lined up with the scope itself. Alright, so ideally what you're trying to do is point the telescope at an object quite far away, get it in the field of view as central as you can, alright, and then adjust the finder scope to what object you're viewing. It takes some time, but believe me, it makes setup much quicker, alright, and you don't need to bother about sorting this, that and other, alright, it's because it's time, precious time wasted. Now, the one tip I always use is that the biggest mistake that guys is put this a mirror diagonal inside, right? They make a lot of mistakes doing that, right? And when you fit it into the eyepiece and then you fit it up, alright, basically what you're doing is you're adjusting the actual focus and the image. So the ideal tip is if you're doing a alignment, or you're trying to focus an object, especially for the fine scope, you set it into the eyepiece like so. Don't use a mirror diagonal because it adjusts the focus plane. Ideally, you focus the image, get it lined up, you just need the crosshairs, perfect. One thing I need to let you guys know, is that this is a 1.25 illuminated reticle eyepiece. Alright, it's 12mm. It just depends on what telescope you use, but this one, believe it or not, gives me near enough same sort of focus that I need to get this focus I need perfect, which goes with the QHY IM3 too. It's got a built-in reticle. I found it very useful not to use a mirror diagonal, lock it in place. When I focus an object, it just screws. The reticle itself does illuminate, and it will give me the exact sort of image that I want to. Once this is set up, it's basically, once it's all focused and it's perfect in line, you're ready to go. A few tips is that show that planets is relatively small in the sky, even though they're bright in the sky. One thing I found out that when you're aligning the scope, the fine scope, is that it's not always perfectly accurate. Now, you can get some fine scopes with built-in reticle eyepieces that's built in with the fine scope, but they're relatively a lot of money, and it can cost quite a bit, probably 80 to about 90 euros, which works out around about 60-70 pounds. Quite expensive. Yeah, it makes it a lot easier to use, but why sake of wasting money? And the biggest problem is when you're lining up is that the reticle is not illuminated on the fine scope. So what you could do is use a red torch, something like this, quite dim, and if you're lining up against a star, or you're going to line up on the planet, right? But obviously for star alignment it's very crucial you get the star central. Now for the planet it's also equal as well. And basically you just shine it slightly over the fine scope, alright, just enough so you can just see the reticle and it doesn't blot out the stars, alright. It's another quick tip that I've noticed, and if you just shine it over, you can see the reticle. So you just slightly over, say like Jupiter, you can press escape twice on scene scan, alright, it will then say go for realignment, and you just see the keypad, alright, into view. Alright, once it's in view, hopefully if your finer scope and your main scopes are aligned together to each other, you should get Jupiter within your imaging camera. Alright, it's another quick little tip. Another problem is obviously cool down varies, alright, but also you've also got the problem with dewing up. Basically, this lens here collects moisture, alright. If the cold air or whatever is damp, alright, it's a good idea to get yourself a dew shield. Now it doesn't have to be a specific dew shield, you can just use a bit of rolled up cardboard and just wrap it around the tube like that, okay, and then it will protect the scope from dewing up, alright. And increase your chances of imaging for longer. Alright, doesn't highly stop at all. Alright, because dew will get in there. Also with this one is I can connect a heat element, a dew zapper element, control box, and power off by a 12-volt supply, and I can fight off dew all night. However, you just use a piece of rolled up cardboard. This is fine. Alright, and it will fight off dew no end. As I mentioned before, is try and avoid using the mirror diagonal. Alright, if you put an extra part in the focus train, you'll probably find that your images will be out of focus. Alright, so try to use a straight through eyepiece with the star alignment, and get an eyepiece that will be similar sort of focal plane, more or less, with the imaging camera. Now, because the Planetary cams or webcams, believe it or not, this is the webcam, but obviously this captures high frame rates. Webcams are ideal. You can take between 10 to 20 frames per second, alright? And planetary cams, which are dedicated webcams for planets and the moon, alright, cost a little bit more money, but it is actually quite a good investment, alright, just to pay that little bit extra. Alright, this is quite an expensive one. There are cheaper variants out there, ranging between 150 to 250 pounds. Alright, but you know, these are dedicated planetary cams, and we just slot straight in there. Alright, quite simple to use, and you can start imaging straight away. Now, the reason why webcams are alright to a certain degree, but you can always push to a certain limit. Alright, they're not going to be higher resolution compared to these cameras. These cameras will provide a lot higher megapixel rate. You're going to get better images with these dedicated webcams, and the frame rate. Now, the frame rate is basically higher the frame rate. Now, if you're looking for between planetary cam, a good planetary cam between 40 to 80, maybe even 100 frames per rate for a dedicated planetary cam. Right? Higher the frame rate, the more chances you're going to capture all the hidden detail. Now, what I'm trying to say is that the detail that you're going to see is basically the Earth's atmosphere is not always perfectly steady. Alright, and what I'm trying to say is that the Earth's atmosphere shimmers, alright, and all the air currents within that atmosphere ruins the image. So you basically get a ripple effect. Alright, that is completely normal. Alright, some nights vary from night to night. Alright, some are really steady, and some are just impossible to image. But what you're trying to do is, you're trying with the higher frame rate is capture just a few milliseconds of moments where some parts of the detail is basically steady in certain parts, because obviously you're going to see pockets of clear parts now and again. That's why when you're looking through an eyepiece, a lot of beginners make a big fault if they're looking at the planets doing visual work, is that they look at it instantly and just move away. You're supposed to study the planet, keep on looking, and you'll be surprised on what further detail you can see. So just focus and study the planet. You know, even if it's like 30 or 40 seconds, you start to see certain details will appear and disappear. Alright, this is the same applies to webcam imaging or planetary imaging. Alright, so a lot of people make that mistake. Alright, don't make that mistake. So with the higher frame rate, it captures a certain amount of this light, and what you're trying to do is, obviously this is linked up to my laptop, alright, just by USB. That's all it is, USB. And basically, this will capture all the hidden frames, alright, and what you're trying to do is stack, alright. Now, believe it or not, for planetary imaging, you do not need dark skies for planetary imaging, but you're not. Here I set up here within the town area. Alright, there's no requirement to go to remote sites for imaging on the planets. Alright, this is only applied to DSO astrophotography or deep sky objects. These are not ideal conditions for them for deep sky imaging. However, for planets, you can do it in your backyard, in your garden, yeah, and that's how I set it up. Now with this, is that certain sky conditions, alright, it varies from night to night. Obviously, the steadier that air becomes, the better the views will be better, right? And your imaging, you capturing all those images, you're going to get a better imaging as well. Also, you've got to think of is, as I mentioned before, probably one of my guides, is that if you look at the sky, you notice that if you use Stellarium or you run a program, fancy software programs, also with this elliptical plane, the planets, as the Earth spins, it basically the moon, the sun, and all the planets move in this same sort of plane. Now, the best conditions to get the best, steadiest views and images is try and get planets that are between 30 to 40 degrees above the horizon, right? And the reason why I'm saying that is that on certain nights, the higher that planet is in the sky, the more steadier the views and the images will be, right? Because basically what looking through is the Earth's thick atmosphere. Now, if the planet or the moon is below the horizon, you're looking around about 40 to 60 kilometers, probably even more, of the dense Earth's atmosphere through that massive thick blanket. Higher up it is, you're probably looking around about 20 to 10 k's higher it is. Alright, so also use the area of looking magazines on the best positions where the planets are going to be viewed the best. Right, and it all varies from every night and the times as well. Now obviously at the moment Jupiter is really high in the sky at the moment. You can get it at 7 o'clock, at 8 o'clock at night, and it's quite high up. Alright, and that's perfect. That's ideal conditions, is get it quite high up. Right, I believe that Mars is coming up very slowly, early hours in the morning, but it obviously as spring progressed into summer, Mars will be quite visible, so hopefully get some great images from there. Alright, so what I'm going to go do now is that obviously I describe the setup. Alright, first thing is simple. Alright, I'm going to show you some other things as well. As I mentioned before, the reticle eyepiece now does cost a bit of money. It costs about £50 for one of these. Alright, you can use eyepieces, standard eyepieces of like 10mm or whatever, but because of the camera's chip, it can be quite difficult. Now obviously they're relatively small, right, and that's quite normal for planetary cameras. Right, they are very small chips. They do not need to be big wide field chips. Reason for why they're small chips is that with planets being really small, you need to zoom in into the planet itself, alright, and get these hidden details as possible. So you're looking at a telescope with higher focal length is ideal for planets. Now the Maxitov is also known as the planet killer because it's high focal length. Alright, this has almost got an f12, alright, and combined with the camera I can get a Jupiter with quite a big disc with a couple of moons in there, alright, but it varies from each telescope. Alright, with Newtonians are very short focus, so you're going to need a device called a Barlow lens. Now the Barlow lens, right, is basically a lens amplifying lens, and basically it increases the focal length of the telescope. Alright, don't get confused with magnification. Alright, it's actually making the telescope, imagine this is 1500, this will double this to 3000 millimeters. Alright, so that's what we're trying to do. You're increasing the focal length, and what you're doing is you're boosting up that image scale. Right, you're making the image scale on the planets better. Now obviously that depends on every night. Not most nights are ideal, alright, to use high magnification. This is more or less applied to visual, but for imaging planets you can boost it up quite a bit. Now for Newtonians, you need, if you want to get some really good close-up of the moon or Jupiter with its magnificent detail, on Newtonians you're going to look at between a 3 times, maybe a 4 times Barlow. So you need quite a lot, but that just depends on the focal length. Now that's just typical for an f5 Newtonian. Alright, so you're looking between 3 times or 4 times Barlow. For the Maxitovs you don't need a lot of power. Alright, believe it or not, this 127 Mac only needs a 2 times Barlow, and that's it. You don't need too much power. Alright, because then you start running into the image getting blurred and you can't see nothing out of it. This also applies to imaging as well. However, it's quite simple, providing the only main problem is when you use this Barlow is your field of view is going to be even tinier. Alright, so you're even reducing the field of view even more. Alright, and being a Mac, they narrow field of view, so they're quite difficult to aim the telescope. That's the reason why the finding scope has to be perfectly aligned within the main tube. Alright, it can be quite difficult and it does take time to set up, but it's like microns. You have to get it spot on, and it will take time, but the more you practice, the more you get used to it. And it's quite simple. It's relatively the Barlow, you unscrew the eyepiece holder, you slot it in into the camera or webcam, and you just fit it straight through here. That's it. The only problem is that you're magnifying obviously your field of view is tiny, but you're magnifying the image scale, but also your focus will also be out. Right? So that's something you've got to be careful. Now obviously as you magnify the image, you're also magnifying every slight tiny movement, right? Even slight touches. Right? And the planet will be dancing around right left and centre. Right? So what you can do is with a focus is there are ways you can get image focus, but be very careful. Just do slight touches on the main focus wheel, right? That's all you've got to do. Right? And then obviously when you look through your laptop down here, right, keep looking until you get crisp views. Obviously get someone, a good tip is if you're focusing, get someone to, if your laptop's quite far away like this is, right, get someone to either touch the telescope, lightly focus it while you're looking at the image. Alright. Obviously when you're doing a movement, do a slight movement, don't touch it. Right, so you do a slight movement like that, stop, wait until the image, and just keep looking at the image. Alright, it's out of focus, do the same again, light touches, alright, until you get a really good crisp view. Alright, it can be tricky. Again, with the body, slight touches magnifies the movement as well, alright, and it can be quite a pain. Alright, so obviously when using high power, just be aware of that. Alright, I guarantee you from night to night you have one view, get the planet and start imaging, and some nights you're just not going to get anything at all. Alright, you're just going to get bad days or good days. It just depends. Alright, so this is the reason why I set up my telescope. I leave it in the garage and I'm ready to go for planetary imaging. Obviously with this, one thing I have noticed is that especially with this planetary camera, this captures some really high frame rates. Alright, sometimes I notice I can get from between 55 to even about 80 frames per second with this camera. But one thing I did really notice is because you need to capture a lot of the images, you're going to start getting into high frame rates, and this high frame rate can amount up to a lot of memory. Alright, a lot of memory use. So ideally, netbook users, if you're using a small netbook, I have a small netbook. Just be careful, you've got plenty of disk space. Alright. Also, I know it's for planetary imaging. It's not so for diesel imaging that using a netbook doesn't offer the amount of processing power, right, compared to a much powerful laptop. Alright, the netbook's fine, but I noticed with this camera I was only achieving around about 35 frames per second max. Combine it to my Sony Viro all singing 2.4 GHz quad processor laptop, I'll get it to the maximum. Alright, so processing power, planetary imaging does demand a quite high power laptop, alright, because you need this laptop to process the image and capture much of the frame rate, so it boosts the frame rate to a quite considerable time. Now, obviously a lot of laptops are all expensive, alright, but a good all-round one is look between a good laptop between like a 2 GHz, ideally an i3 core processor. Alright, you can get some lower end ones, alright, but get something that's quite powerful with low processing speed, alright, and multiple processors, alright, because I found out that that one delivers a lot more frame rate than the netbook. Another thing is, particularly for this mount, it's not a sturdy mount, alright. It's adequate for visual, it's fine, but this mount is up to its limit, alright. And you can see it does rock about, alright, and it can be a bit of a pain. Now, because of the accessories I've added and the finer scope, is that it's going to be quite tricky. And one thing I have found out is that if you're focusing the image and the planet's dancing around and all that, it can prove problematic when focusing. Now there are alternatives, and believe it or not, there is a proper focusing device where you can connect to the Bahtinov 127, but they're relatively expensive. Alright, so if you can get a motorized focuser that can be fitted and use it, by all means get one. It costs a bit of money, but it makes getting your focus spot on. And the reason why you want to have a multifocus is that you're not touching the mount, you're not touching the telescope when you're just seeing the focus. So I know there's a few people out there. I know that Graham Williams is offering his focuser, which is a fantastic little device that can be fitted onto this telescope. Now it just depends on what telescope you're using. Try and find on the internet, because there's loads of stuff that you can get multifocusers for different types of telescopes. Alright, but they are relatively expensive. You can cost between around about £70 to about £200 for a multifocuser, but it does help dramatically. Now for me, being an experienced astronomer, I don't really need it, to be honest with you. I can get really good focus using a Bahtinov mask, and I get perfect focus. But the multifocuser, it's just a handy accessory. It just makes life a little bit easier. It's not a necessity to have. Alright, you don't have to have it. Alright, you can just do it manually. Get someone to look at the screen, see if it's a perfect focus, and once they're happy, fine, there you go. So obviously what I'm going to do is I'm going to show you a picture of Jupiter. Now obviously for the guys on the forum have seen this image. This is probably the best image I've got of Jupiter for a long time. Alright, and it's using this method. Alright, the 2 times Barlow, the Planetary cam, the Bahtinov. All these things I've described to you, all the little tips, is basically what I've achieved from this image. Alright, but bear in mind is that this image is just one rare moment. Alright, it's not going to be a guarantee. Every night you're going to get images like that. It varies from night to night. Alright, so basically, some days, if the air's not steady and you start the images, and it won't be as great. But some nights, it just varies. Alright, some nights are steadier than others. So you're not going to get 100% the quality that I got from this image. So what we're going to go off now is we're going to show you my picture of Jupiter and see what you guys think. Obviously quite an impressive image, right? And you'd be surprised at what results you can achieve with simple equipment like this. Alright, you can achieve amazing equipment, right? And the level of detail that can be obtained. Now this was just due to my guidelines, alright, and I was absolutely stunned when I achieved that with this scope. So basically I'm going to show you a list of my equipment over there. As you can see before, stole my telescope, I put it in the garage, right, and believe it or not, this is quite protected from the elements. Alright, a lot of people are wondering, well, I don't really want to put a telescope, alright, in the garage, alright, but if it's all locked up and all, there are precautions, alright. You can leave your setup like that, alright, but one thing I found out that if I prefer to pack the telescope away, alright, and I like storing my camera in this little sandwich box, and I pack it all away. Everything I need in here I store away, alright, like so. Bear in mind, as I mentioned before, is once I've put my camera away, alright, I use this device. Now this is mentioned before in one of my guides. Alright, this is basically a desiccant cap, which is homemade
that can be made. Alright, and basically when I finish using it, alright, I basically take the camera off, take it out, I slot the desiccant in there, alright, and that's it. Basically any cold air that's trapped in there will basically, desiccant will absorb all that dampness. If you're storing this telescope in the garage, providing you've got a dew shield, alright, you can just directly put the dust cap on, no problems. Just take off the dew shield off and put the cap on. Alright, there's no need to worry about it. However, if it does dew up, alright, then ideally use a hairdryer, carefully warm up the lens, and I mean very carefully. Alright, you do not want to shock the lens too much. So basically use a hairdryer, slowly evaporate it. Once that's fine, you just basically put the cover back on. Alright, it's simple as that. And that's basically, you can leave this in the garage, alright, all the way, you know, this has been out a few months now, and it's safe. I've had no problems with any dew or mould that's got in there. Alright, and that's it. Alright, and that's all you need. But basically, the reason why I put it in this garage is that I can use the telescope straight away, because it's already at a certain temperature, right, and I don't need to worry about cool down. Alright, but it just varies from night to night. Alright, so basically, as I mentioned before, the equipment, a good planetary camera like this, really good quality, QHY IMG 132E. Alright, if you're really getting serious, right, the webcams are good, alright, and they do give you some fantastic images, but if you're getting really into planetary imaging in a big way, then seriously suggesting getting a dedicated planetary camera. Alright, this is a colour camera. You can get other variants, you get mono, alright, you can get mono cameras which are a bit more sensitive and real more detail, but then you've got to delve into RGB imaging. Alright, so like you say, if you get into it seriously, get yourself one of these, alright, without a doubt. They pay dividends, alright, and you can get some fantastic images. Again, a lot of times the Barlows you get issued are fine, alright, they're absolutely fine for visual. However, if you're going to use a Barlow for imaging planets and using your dedicated planetary cam, then get yourself a really good high quality 1.25 Barlow. This is probably the best Barlow, and they don't even make these anymore. And this is the Celestron 2 Barlow Ultima Basics at ED Apple Barlow. Right. Now there are cheaper variants out there, right, but they cost between around about 40 to about £100 for a decent Barlow. But this is a 2x Barlow, really good high quality optics. Alright, but the reason why go for something like an ED or a triplet Barlow lens. The more lens elements, high quality Barlow, the less of you don't get the distortion or discolouring of the resulting images, particularly in refractors where they suffer a lot of false colour if you use high power. Obviously this will minimise some of the false colouring to certain achromats, but not all. Alright, but it does help. This is handy for the Maxotovs and the reflectors. Alright, but invest in a very good high quality Barlow if you want to progress on really good planetary images. Alright, this is fantastic. They don't make it anymore because this costs around about £90. But there are some out there. I believe the Celestron do the XL Cell series now, which have got really good Barlows with 4 elements. This is only a 3, but this has been selected. Quite a few astronomers have kept this because it's such a good Barlow. But again, you don't need, you can just use basic Barlows. Alright, but this is just basically just for if you want to do serious planetary viewing or imaging. As I mentioned before, I mean, there's not much of a setup really. You don't need a lot of equipment. Now, this is just a few hints and tips, alright, just to give you a good steed on getting the best possible images. But what I will do is I'm going to go back to my house, and we're going to show you two programs that I recommend using for planetary imaging. Alright, and I'm going to go in a little bit hints and tips of detail, alright, so you can get really fantastic images. Hi everyone, back to my computer, and I'm going to show you a few capture software programs. Reason why you need a capture software program is that you need to collect the raw data into AVI files so that you make a recording of planets between around about 10 maybe up to 90 seconds of film of the object you need to capture. Now for a lot of webcam users, we use a program called Shortcut. Now at the moment, Shortcut are launching out a new one called Shortcut 2, but it's basically going to be used for the newest webcams that's going out in the market. Now, one thing I did find out is that Shortcut 2 is relatively new, and I found that some of the older webcams didn't seem to work very well, like for example the Logitech 3000 and the SPC 900. So all the webcams, the older ones, don't seem to work not very well with this Shortcut 2. So basically, I use Shortcut is around about 1.5, which is basically it's an old variant, but it seems to run quite well for the older stuff. Now obviously when you're capturing, first off is once you've got the telescope inlined and you've got Jupiter, for example, it's in the field of view for the telescope, for the eyepiece, you then set up your launch Shortcut or another capture program, and then basically you can once you get an image, imagine Jupiter's just there, right? But obviously I'm just using my webcam. Now obviously it's easy to do. You just click on File. You can set up your capture program folder, right? So you basically all your AVI files you can set up your folder and put your files there. Alright. You can select different cameras, alright. Depending on the drivers, if the driver's been fitted and Shortcut recognise it, you can use different cameras. One thing I have noticed that Shortcut can be used for long exposure photography for deep sky objects, but today I'm not going to go into that. I'm just going to basically go for normal webcam capturing for the planets. You've got a series of options. You can select options in night mode, so it protects your night vision. Nice little feature. And you can do other things as well, but I'm not going to go too much in detail. You can start capture from the top from there, or stop the capture. Here is basically where you start your capture, and then you can either make a snapshot. Basically, you can make a single, single picture on this tab here. Also, one thing I do like about Shortcut that most capture programs don't cover is this. I particularly like that. That's basically a reticle. Alright, I found that really handy. Alright, fantastic way to line up your planet in the center of that X. And the good thing is, when you're capturing, this X is not shown. Alright, so don't worry about the X being in view. But once your image is planet is in the center, you can just start capturing. It's really quite handy to have. Alright, you can select your zoom. You can basically zoom in the picture, which gives a nice little handy feature of making your images slightly bigger. Alright, but that just depends on the camera if you can do that. Again, this is where you can load up your files. This bit here is the compression. Now, I'm not going to go too much in depth with that. That's basically what type of compression. Most cameras run on YU-Y2, and obviously it tells you different resolutions. You know, basically what size picture you want. You can have a 160 times 120 and 320 by 240, but best setting of all is 6 by 40 by 480, which is the best possible field of view you can get, particularly for webcams. Now, obviously that just depends on what webcam you have. All the ones will have a narrower field of view than that, but I know the SPC 900, the Philips webcam, and the Logitech run on that mode anyway. And then you've got this setting here, frame rate. That's really important. Obviously, higher the frame rate, it basically makes it more quicker. But bear in mind that some webcams can't exceed that. Alright, so if you get to 30 frames per second, I think a lot of webcams will struggle on that setting. But usually, ideal setting, especially for the Philips and Logitech, is between 15 and 20. 20 is you're really pushing it. But that just depends on the webcam you're using. Assuming you're using 30 frames per second, that is the most you can do on this capture program. You can't go any higher. So if you have got a QHY AMG 132E, you can't get above that. Alright, so that's where the capture program lacks a bit. Apart from that, it's like any normal capture program. You start the capture, alright, you click on capture and it'll ask you how many frames you want to take. Alright, you can take a single frame or limited frame, which basically keeps going, number of frames, or you can do a time limit. Alright, you can set the amount of time. Obviously, bear in mind that some planets, like Jupiter for example, there is a time limit on there. So 90 seconds is usually the most you can get for imaging Jupiter before you start getting field rotation, which means the planet rotates that quick that the features have lost because the planet is rotating, it's spinning. So you then get this blurring effect, which means that you're going to lose a lot of detail and contrast and so forth. So really 90 seconds is what you're pushing at. And then once you're happy with it, you just start it, alright, and it will just start up the image. Alright, it's quite simple to use. So assuming we're going to start capture, I'm going to start capture, I'm going to do 20 frames. Or you can up the frames, you know, the more frames you have and all that. Or I prefer to do time limit. Right, so basically it'll come in hours, that's minutes, or you can do seconds. So we do 30 seconds for example. So we press start. Alright, it starts doing the capture, it stacks them out frames, how many frames per second it's capturing at. Alright, and it's basically just capturing as it is. Now, what is missing is then you've got like things like gain and exposure on this, right? Because I'm using the normal webcam on the computer, right? Alright, it says it's captured there. Alright, fantastic. I'll do that again. It seems to be a bit of a flaw on that because that option wasn't there. So we do it again. Again, this is the gain. This is what you use mainly if you're trying to find an object, because particularly if you're trying to find it, you really up the gain as maximum as you can. Alright, you put it up to the full whack. Alright, and that will enable the planet you're trying to view to be overexposed and be brighter. Alright, and same as gamma, you can up the gamma. Alright, it's very crucial that once you up the gamma and the gain, as soon as you got the object into view, alright, and then you just basically, once you're happy it's in the field of view of your camera, you can start capturing. And then basically what you're trying to do is you lower the gain to a manageable level. Alright, you can up the gamma if you wish and so forth, but ideally you need to get it so that it's so that you've got a reasonable sort of image. One thing I have noticed that there is no settings for like adjusting colours, so you can't adjust the red and the green and the blue colour bandwidths. It doesn't allow you to do that. But it's fantastic little program. It works quite well. Obviously, it is mainly for the dedicated webcam users, right? For the non-webcam users. However, I use another program now. I'm going to click out of that. Another program that I use is Planetary. Alright, this is dedicated for the IMG 132E. Again, what you can do several things. It's like every typical capture program. It's basically the same sort of layout. Alright. You can, on this one, you can adjust the color balance of the image. Alright, and it's quite handy to do. Alright, and here you can capture some you can adjust the levels and do some lot of capturing on that one. Dedicated for the IMG. This enables the camera to capture at high frame rates. Now, one thing I have noticed is when I'm capturing images, webcam images of AVI files, there's a big problem. When you're capturing at such a high frame rate, you start going to big files, and I mean over 2 gig. Now, what's the problem with Windows 7 is that as soon as you get to that limit of 2 gig, you can't record anymore. It does not allow you to record too much memory. So thanks to a guy called Brian Ritchie, he gave me advice of using a program called PiPP. Now, PiPP, what that does is, as I click on the PiPP, what that does, it enables you to join 2 separate AVI files together, alright, so that you can stitch them together as one AVI file. Alright, so you get different source files. You can add your AVI files together. So as with PiPP, say that we've got this image file, we're going to add that file. So we've got to add image, alright, and we're going to select that one, and we're going to click on another file and click on that one. Alright, so, and as you can see here, we've already got massive files of 1.77 gig. Alright, and they're around about 45 seconds, believe it or not. For some strange reason, you know, these are the amount of frames that are stored. So it's around about 4,000 frames being collected. Now, there's the files of 4,132 frames. Alright, you can either separate them or join together. So what we do is we click on join mode. So basically I'm going to click stitch these 2 IVI files. Now the one thing that I suggest you, if you're recording and you go over that limit, that AVI limit, it'll stop recording. Do it again straight after, alright, straight after that, and do another recording until you reach 2 gig. After that, for this particular camera that I'm using on the QHY132E, is that these are at 45 seconds, so 90 seconds is probably the most you can get out of this to image Jupiter. For the others you can do quite a lot more, but with this we've just managed to collect 90 seconds of data here, right, and it enables me to capture this amount. Once I join the join mode, you can optimize different options, like for planetary, you can do a solar, lunar, close-up, planetary animation. There's quite a lot of stuff, but I prefer to select planetary. You can also debayer the images so that it basically takes out some of the information, stacks it, and then puts it back. Alright, but I tend to leave all these settings alone. You can also, if you click on that, you can also add your date and time and all that if you wish, but I never bother with that. You click on processing options. There is a range of things you can do there, and you can even rotate it and all that of the actual quality of the images, but I've never actually bothered with all this. I just left it as it is. Again, you can enable estimation, right, and you can pick how many frames you want to keep, right. So I up the frames. Personally, I like to keep all the frames, so I basically pump it up to the 4132. You can also just type it in. 4132 is the amount of frames, right. Basically I want to keep all the frames, alright. Now the reason why I'm doing that is that I want to keep all the frames, because basically I'm going to stack all of them into Registack 6. Again, there's a load of stuff there. Now I'm not going to go too much in detail. You can either compress the AVI files to something more manageable, but I found just leaving it to AVI setting is better. Plus AVI files tend to work better with Registack 6. If you try any of the others, Registack 6 just does not like it. I go straight to do processing, and basically what that's going to do, if I start processing, it's going to stack, it's going to combine all those two AVIs into one. Now it'll take a while. Okay, it's now stacked the images, and basically it's now stacked a complete AVI file, both of them together. Now the program can be used as a stacking program as well, which is similar to Registack 6, but I skipped all that because I feel that Registack 6 is easy to use. And basically what it's done is, with this capture image now, basically this is 2 AVI files that now exceeds over the 2 gig limit. So now basically now it will give me a complete AVI file, and you can see what I mean about this shimmering. as you're taking the image, this is completely normal. Now obviously when you're webcam imaging, you want to really set the exposure quite high. You need to set the gain quite high when you're using high magnification. But obviously this is quite dim. Believe it or not, this was on the highest gain, but set quite low exposure. So it's relatively noisy in the image. But the whole idea is that focus is really important, and you can see how it shimmers. Alright, that is the Earth's atmosphere. Alright, this is completely normal. Believe it or not, this is actually quite good seeing. Compared to some images, it varies from time to time. But with this image here alone, now ignore this timer. This is not the actual timer you'll see on the exact. It's basically 90 seconds of each. Alright, and obviously here you've got your timer here and your exposure as it is. Alright, so that's basically your complete file. Okay everyone, I'm going to show you some examples of video footage which I've taken with my Skywatcher 127mm Maxutov telescope with my Planetary camera, which is the CMOS QHY IMG132E camera, and I'm going to show you a few examples of what you can achieve with these images. Again, I've got Jupiter. It is relatively dim, but the thing is with planetary imaging, you don't need to overexpose. If you put the gain up, you probably find that you might blot out all the detail. So it doesn't have to be very bright. The only reason why you up the gain, so that when you up it, you can make the object much brighter. So when you're trying to locate it, you're trying to find it easier on screen. Right, that's basically what you're trying to do when you up the gain. Also, when you overexpose using the gain, you're also revealing some of the moons on there, or some that's quite dim. Now it just depends. Here's one with the gain slightly increased a bit more. Now again, these relatively windy night, as you can see the Jupiter's dancing about. Even the slight touch on the mount, because you're using high magnification, vibration is more prominent. Even if you've got a really good sturdy mount, you'll find that even the slightest touch on that mount will jiggle about, because you basically, as you're using Barlow lenses, this will amplify the movements. Now this is just a non-Barlow lens. There's no Barlow lens fitted on this, so the image scale is quite small. But you can see these are relatively steady nights, and I'm going to show you one of Jupiter closer up, and you can see now you can see all the detail there. Now it looks like a blurred image at first, but it's actually, the planet is focused quite, it's spot on focus there. Focus is very crucial when you want to achieve to get this fantastic image. Bear in mind, when you're using high magnification with a Barlow lens, depending on the size aperture of the telescope, you might need to up the gain. Now this gain was upped to the maximum to get Jupiter just barely visible in this image. And you can see when you up the gain, it creates all this noise. Now don't worry about the noise, alright, that's normal, don't worry about the noise. But what you're trying to achieve is, you've got to try and achieve to get that image in there and get all this detail. Now this is probably the sharpest conditions I've had so far. You know, so these are very steady nights. But believe me, time after time it varies, and it varies a lot. Sometimes you might not even see any detail at all. You know, because you could probably find that the Earth's atmosphere would be so unsteady. You know, Jupiter might even just appear as a featureless disk. So it just shows you. Now these are good sky conditions. It does shimmer. It's completely normal. Alright, but this is a very, very extreme close-up of Jupiter, and you can see, if you can achieve results with the Barlow lens, you've got to have good steady skies to get this. Now, one tip that I found it seems to work for me is, as I mentioned before about planets being, you know, the best time to image or view planets is get planets that high up in the sky, and obviously planets that move along this elliptical plane, you know, as well as the moon and the sun and all that, but they basically move in this elliptical plane. Now if you try and get a planet along there quite high up, you can get you're looking through the finished proportion of the Earth's atmosphere, and that will greatly affect your views. So if higher it is, the more clear the image is going to be. Also, to point out, another tip is look at the stars in the sky. Look at the stars. Now, if the stars start to twinkle, it gives you an indication that the Earth's atmosphere is extremely unsteady, and there won't be ideal conditions to image planets or view planets. But it doesn't stop you from not taking them. You can take them, but as you stack your images and you compare the exact same images, say like you did obviously an image of Jupiter, and the night before, you compare each of the one, and you probably find that one is more steadier than the other, and the details are shown more. Alright, so it does vary a lot. So obviously these are very good sky conditions in this image here, this video footage. So it just shows you that every night is different, no matter what. But that's the secret between planetary imaging. You've got to get the steadiest skies possible. Now, one thing I have noticed when using my IMG 132E camera is that I'm starting to hit high frame rates, and believe it or not, these clips are only 45 seconds, which is quite surprisingly, but the amount of frames and data that's being collected with that 45 seconds exposures, basically it's running to like a 2.5 to 3 minutes film footage, believe it or not. So these aren't that long. Now the problem is with Windows 7, I don't know about Windows 8, that once you start recording, you're going to start getting to massive file sizes, and these AVI files can be up to quite a bit. Now Windows 7 restricts amount of video recording to 2 GB of memory. Once it hits that value, you can't record anymore. Now, thanks to a guy called Brian Ritchie, he suggested the idea, which he uses a program called PiPP, and what this program does is it enables you to stitch AVI files together so that you can combine them together. You know, say like you've got a 2 gig there and you've got another 2 gig program, you can stitch them together to have a 4 gig video footage. Also, what PiPP does is it centralizes Jupiter in that field of view, so that if it's dancing about, basically PiPP will focus it dead on with the planet. So when you stitch them together, you have the planet central, and it will be, you know, if you say you've got a windy night and all that, it's not going to go everywhere off the picture. So basically what that PiPP enables you to keep it focused in that film frame, which is another fantastic function. So obviously the reason why you're using PiPP is that you need as much of these frames as possible. So when you do stack them, you get a much better image quality. The more frames you get, the better that image is going to be. Now the trouble is with Jupiter, as I mentioned before about the blurring, you can only go to like 90 seconds. I know there's some people that manage to take pictures for longer, but I'm not going to go into that because also I'm still learning through this as well. But obviously to get a picture like that is the best Jupiter image I've got so far. Now as I mentioned before, it varies from night to night. If you've got steady conditions, you can get really good images like that. Now I'm going to show you an image here, which is, again, this is Jupiter using the same equipment, and again you can see, yeah, I've managed to get the moon, one of the moons casting shadow onto the surface of Jupiter, and I managed to get a slight red spot there. However, as you can see, Jupiter was quite lower on the horizon, and you can see that being quite low, looking through the thickest part of the Earth's atmosphere, you can see that, yeah, you can just see the cloud belts, but they're not easily defined. And you can see that straight away. You know, it's not very clearly defined at all. It's a good image, don't get me wrong, but it's not clear. Also, one thing to mention is that focus is really crucial. You've got to have spot on focus. So if you're slightly off focus, this will also depend on how clear your image is going to be as well. So you need to take that in mind. So obviously it just varies every night, and you just need to do a lot of practice. As I mentioned before about gain and exposure, you've got to keep a balance between the two. Now, gain's very handy when you're using very high magnification and you want the planet to just appear. But be very careful not to overexpose using the gain, because what you do is you're going to lose all that finer detail within the planet. So be very careful when you overexpose using gain. So be careful on, you're going to keep the balance between the two. Also, when you're using the exposure rate, you need to maximize the amount of frame rate. Alright, so you've got to keep a balance. Right, there's something else I need to add. Is there's a lot of members that are a bit stuck on planetary imaging, and the one thing they're getting confused between the exposure and gain. Now, trouble is though with gain and exposure, gain is basically increasing the brightness of the object, and exposure is increasing the frame rate. Now there's a few people who got a bit stuck between the two. Now gain is usually important if you're trying to use high magnification and you have to increase the gain so that it just appears. Exposure is the opposite. You have to lower the exposure as down as possible, even though if it dims the planet really, you know, quite dim. What you're trying to do is you're trying to maximize the amount of frames to be collected.
Now if you increase the exposure, you're going to lose frames. So try when you take a live footage, lower the exposure as low as you can. Now believe it or not, this exposure is around about 0.4 second exposure. It's really quite low, but the gain is increased to the max. So even though it's a noisy image, but the frame rate is around, on this camera I was touching around about 57 frames per second. Now if I up the exposure even more, I'll be lucky till I get 6 frames per second. So what you're trying to do is you're trying to maximize the amount of frames, even though the object appears really dim. But don't worry, don't let that bother you, because with stacking, I mean, here is a stacked image of Jupiter. Alright, don't worry about this line here. Right, this can be cut out. You can crop this image in Paint Shop. Now this is a stacked image, and as you can see, you can increase the gain and all that, and you modify it, and the brightness will increase more. Alright, and you can see Jupiter with all the detail and all that. Alright, so obviously once it's stacked, you can post-process it using Photoshop to increase the brightness, and the details get revealed. Alright, and it just shows you using Paint Shop, you know, increase the contrast, you can change the colours and so forth. Alright, and you can see for yourself, you know, how much images go about it. So to all you guys who think, oh, I've got a very dim film footage, don't let that concern you. All you're bothered about is getting the maximum frame rate you can achieve possible, and also to a certain length of time as well. Now obviously with Jupiter being a fast planet, 90 seconds is really pushing it, so just bear that in mind.
Right guys, another way to able to get your perfect focus is get yourself one of these. Basically this is a Bahtinov mask, and you can get them in different sizes. Obviously this one is made to fit a 5-inch max cutoff, but you get different sizes to fit different scopes, so make sure you get the right one. They cost between around about £10 to £20 depending on the size. Obviously bigger the diameter of the mirror or telescope or lenses, more the price goes up. And basically how this works is that you basically, this kit here has 2 bolts, so I'm going to fit the 2 bolts here. These are just nylon bolts. They fit through the holes. Like so. Alright. And then you just simply fit it over the telescope, like so. Alright, and then what you do is you focus on a bright star, and what you're trying to do is trying to get these 6 spikes lined up perfectly. Alright, which I will demonstrate further on the laptop. So obviously I'll show you how to do it. And what I do is you basically focus it till they're all lined up, and that will give you perfect focus, which is very crucial for planetary imaging.
Okay, I'm going to show you now how the Bahtinov mask works. At the moment you see a picture of Betelgeuse. Alright, and what you'll see is if I throw this out of focus, see it's all blurred. So you keep focusing it. Now these aren't ideal conditions. As you can see, there's the 6 spikes lining up. Keep doing it. Start to see a bit of a pattern now. I can see 4 spikes, but you need to get 6 spikes. So keep going. Now I'm out of focus now because I can only see 2 spikes. So I go back. Also I've gone too much. So I go back on myself. A little bit more. And that's what you try to achieve. I've now got 6 spikes now lined up, which means that now the Bahtinov mask, now the telescope is now in focus. So the telescope's now in focus. Now obviously the sky conditions aren't great, but that now is focused with the Bahtinov mask, and then I can start imaging Jupiter.